worry about the stuffy situation there. I won't trouble you for a long time. I will make my speech shorter possible. It's okay with you?
Yes, sir.
Okay.
Sir,
Thank you so much, Tapan ji, for helping me to be invited to this university. I have been hearing from Tapan ji about the university quite a bit. And there are many students who came out of Jadavpur University in ISRO. I think we should give a huge round of applause for their contribution to the During my service, I was really fortunate to come in association with many of them who serves across the country in many centers, including where I worked at Trivandrum, the Vikram Sarabhai Space Center, the Liquid Propulsion Center, and other ISRO centers across various parts of the country. So, hats off to all of you. And I know Jadavpur University is a very long history, legacy, and contribution to the nation in the domain of, specifically the science domain, engineering domain. So I wish you raise your flags higher in the years to come. And especially I'm very happy to see young faces here. A lot of you. I think all of you are excited about space and science, is it not?
yes, sir.
So that's why I came here specifically packed a talk. What it is there for you. I think how you can make leverage on this domain and find some possibilities either in studies, in research, in entrepreneurship, in innovation, in business. I think this is what I want to talk to you, and I want to introduce you what is happening in this country at this moment. And also while I speak about that, I would like to go back a little bit about our journey in space. And it has never been easy. Space is not an easy domain. It has also gone through a lot of tough issues in the past. Little bit of glimpse of into it so that you will be aware of what exactly the domain that you are getting in. Also, you are with me, right?
Yes, sir.
So what excites me in space is always this. Possibly somebody can switch on the slides, it will be good. Okay, so you can see the slides properly. So, see, all of you look at the sky every day evening. Is there a good sky in Kolkata?
No.
You can still see the stars.
Yes.
Okay, good that there is not enough pollution there that prevents. If you go to Delhi, you can't see stars, no? They have forgotten seeing stars. But I believe in Kolkata, you still see stars, right? Okay. But even not able to see our galaxy. Have you any time seen our galaxy?
Yes, sir.
No, never. For that you need a much clearer sky. But what I wonder about me is that always is this picture that I'm such a silly person standing on one of the forgotten planet or on a dust like this in that big frame of things, and we claim something very big. No, in the vastness of the ocean we are still insignificant. I think this is very poetic in the sense it's equally very complex to understand this domain. And this is why it is so exciting for me, and space is such a domain that gives me so much opportunity to get excited, to explore, to understand, and always wonder about the universe. Is it not? I think all of us, whomever I speak to, young people, boys and girls, are always excited to become, and many of them come and tell me, I want to become an astronaut. I want to become an astrophysicist, without even understanding what exactly it is. No? So this is what really happens across various schools and colleges. I go and talk to them. Not you people, you are already educated enough to understand what exactly it is. I'm not talking about you. I'm talking about much younger kids who really want to just get excited and understand. I think excitement is still very, very important in this space, and that's why we keep Tapanji and me into this domain for such a long years. We have been working here for last 40 years. 40 years is such a long time, right? You still get bored. And I don't know if you can work for 40 years. I am guaranteed this generation cannot work for 40 years. But at least you can work for 10, 15 years in one domain. It's great. So, but the most important part is to get excited about what you are going to do. And this is where it's important. And while you work on excitement, it's always interesting to look at future. You know that guy?
Yes, sir.
Yeah, Stephen Hawking. He always speak about this one aspect of space technology. It is human beings. They are dwelling on this planet, and whether they will dwell on this planet forever, or will they become a multi-planet species at some point in time? Because it is important for us to travel across the universe and then populate ourselves as life forms. That we are an intelligent life form. Do you agree? Are we a really intelligent life form? I believe it. We are. And if you believe that we are an intelligent life form, it is our responsibility to survive It is our responsibility to spread, and it is an important tool that we have in science and technology. And space science specifically enables us to understand what is there outside the universe. You heard of exoplanets? I think all of you know about it. I should not speak too much about it now to you people. But then it's important to look at such view that are there about science and technology and to be excited. I think I just showed you this slide for that purpose. But then for us, way back in 1960s when we started the space program, we were launching small rockets from Tumba. But then America was already on the moon. You know that they were already placing a man on the moon, and we are struggling to do our Gaganyaan program. You know that. So the gap that existed between us, US and India, in terms of science, technology, capacity in space was so much different. You know, about 50, 60 years of gap that existed. But then over a period of time, we were able to bridge that gap and build certain capacity in India. Today we have landed on the moon, right?
Yes, sir.
And it is not an easy task at all. You know that for a country like India spending just 1.8 billion US dollars annual budget against a giant which spends $50 million. We are able to do this in India. It's really phenomenal using homegrown capacity and technology. And with such a small amount of money and such a small number of people who are working. I think this is something which you should always tell and speak so that future we cannot remain like this all over. No, we need to really grow. And this growth will happen only if you do certain things. And this is something which is important for you people. And when we started early in 1960s, we started with collaboration. We brought rockets from America, we brought launchers from some other nation, we brought computers from some other nation. We integrated and launched the first ever rockets. An American built rocket using Russian computers, using French capacity. And this was important for us because we believed in collaboration, cooperation, bringing knowledge to everywhere. But then when we actually landed on the moon, the same nations put up such cartoons. Now you know that these cartoons come, and I consider this cartoon as a compliment, not as a criticism. No, don't look at it as a criticism. For us, a farmer knocking on the door and I want to be a part of your space club, it's a proud moment for us. I think it should be that way. So we believe that doing things in a frugal manner, doing things at less cost, something very phenomenal. After Chandrayaan 3, when I went toured some places outside India, they were all asking me, how did you really do this at this cost? And what is the nature, the psyche within us, enabling us to do it at low cost? I said, I will not tell you the truth. No, because it is something which is very close to our heart and how you do it at extremely low cost. Because if you talk about high cost, something which will never come to us, government will say don't do it. Okay, so we will always do it at low cost, and we want to specialize in doing it at low cost. But there are a lot of elements to it. I will discuss it later. It is very important for us to understand how things are done at extremely low cost, frugally. Innovation becomes an inherent nature of our engineering capacity. So I don't know whether it is being taught in colleges. How many of you engineering students? A lot of you. I think I don't know anyone are being taught how to do things frugally, how to create innovation. I think Tapanji was the director of innovation in ISRO, and he maintained that activity for a long time to capture young minds who have ideas in the country. But then, when we talk about rockets, this was the time when I joined. The early rockets, the Kalam just made the SLV and launched it successfully 2 times. The program was closed. The next rocket called ASLV started by the time I joined, 1985. But all of them were failing. And when I joined ISRO, there was always desperation there. Nothing was successful. Satellites were not built, communication satellites were not there, rockets were not going all right at all. And ASLV was always sea launch vehicle because it was always going to the sea. So then we had no motivation to work. But what was most important for us, it was leadership that was shown by my bosses who were there, towering people, who talked to us, mentored us, convinced us that you should stay in this organization, work hard to make sure our country develop capacity. Though we analyzed rocket failures in great detail, but when you saw a rocket bending and breaking like this, I don't know whether you are able to see the picture very clearly. It is very disheartening to see a rocket which was just there at the launch pad going up and breaking into pieces. Now if you see your own baby breaking into pieces, you should imagine what type of pain that you will have. But from the pain, we decided that we will work very hard. We will work and understood that our knowledge in this sector is not enough for us to build it. We were still making the baby steps. Our understanding of rocket technology was still not ripe enough to make a successful rocket. And this is precisely the problem the startup companies are currently facing. And many of them are building rockets, but their understanding is not good enough because it requires years of hard work and assimilation of knowledge. So it was a journey that we were going through at that time. But it was not just enough that we see failures. We need to understand it, build our capacity. So this was a journey when I joined PSLV project. We were going through this struggle. But my mentors at that time, I will show some of their photographs because I need to salute them. To tell us how you will mentor your students, your young engineers, possibly your professors are doing the same here. I hope that to understand failure, solve failure, problem solutions, coming out of the solution is such a tough thing. And recently we know 2 failures have happened, PSLV failures have happened, you know that? 2 failures happened and we just completed its failure analysis. We found out it is not a very serious problem, it is a small problem which you should solve and come back to this back again in the launch. So in rocket business, failure is very much a possibility if you are not maintaining certain credibility and work culture. And this was not the case for other rockets as well. Our GSLV also failed multiple times. And I was there in ISRO when we saw the failures. It was always disheartening. I was a member secretary of many of the committees to understand what went wrong with the rockets. And through this process, we learned quite a bit. I am a mechanical engineer. How many of you are mechanical engineers? Oh, great. I think congratulations to all of you. And this guy is an electronics engineer. We always look at electronics engineers not with great respect. So we say royal mech. Now, how many of you are royal mech? Okay. So we say that royal mechanical people are the ones who understand everything, and electronic people understand only electrons, which they have never seen till now. So that's just for fun, but I respect all of them because the technology that they have brought in electronics is so great in terms of the revolution that they have brought. But if you look at the rocket as a mechanical item, it has not changed for centuries. Ever since the rockets were developed, the Konstantin-Tsiolkovsky rocket equation, the propulsion, the structures, the materials, the complexity remain almost the same the last century. Whereas electronics has gone through dramatic changes and evolution in terms of technology, compactness, power, intelligence. I think it is something phenomenal. And that is enabling better mechanical engineering today. So we are friends today. Electronics, computer science, mechanical are all friends today. Today we talk about computational mechanics, computational material science, computational chemistry, computational biology. I think things have changed today and we started understanding that engineering is not one domain, engineering is an integrated domain extending over many domains, and that's how we become a better engineer. So change your approach to it. But again, the topic I am talking about is failures. I think failures has been a great lesson for all of us to understand what are the subtle issues that will cause failures. Have you seen failures? How many of you failed in your last paper? Okay. I think it's all good. And if you have failed, I think you are taking a great lesson and how not to fail next time. And I can guarantee you that doesn't mean that all of us should be gold medalists. The successful people are the ones who understood why you failed and made a correction next time and came out successful. So congratulations to all those people who failed last time. Okay. Another important point I want to tell you is to do great things, you need great management. So something we call project management. The structure of project management in ISRO has been really phenomenal. I have been really very happy to learn this along with doyens of this work which we have done. In creating, how do you really break down complex problems into small problems, assign to people who have a competence to do, integrate them to build the big one. No? This is a very crucial aspect of engineering. And this must be taught in class. I think system engineering, breaking down system into smaller one, and tracking engineering and understand interplay between them. And this is something called project management. We have specialized and created that. Much before IAM started teaching project management, we practiced project management in ISRO. I think this is something very phenomenal. Similarly, we followed something called quality management system. I still remember my bosses who were there at PSLV came from SLV3. In SLV3, when they were discussing this, how to implement quality management systems, there was so much opposition. What exactly you by quality? I know what I am building. Who is there to check it? How to verify it? I am the expert. Who are you to verify this? You do not know about anything about it. And we changed that approaches and said that it's important for someone else to look at your work to say you are doing it good. And we created oversights on work that you do. Today, quality is a topic which is specialized. You know, you heard about it, no? There are a lot of standard approaches to quality. And this was learned in practice there. Similarly, change is something which is phenomenally impacting success. You do something today, you do change it tomorrow, then it won't work. And you don't know when you do something, a little bit of change, how it impacts the overall behavior or performance or something. And this, if you do not understand, you cannot make things successful. Controlling change is a very important role of operational systems, and that's precisely the reason the PSLV failed. I'll give you the secret of the last two failures. Though the report has not been announced, I can tell you the reason behind all of this is that when you do approach some complex problem, you should understand small changes can create havoc, and you do not know how it interplay creates multiple issues. So I will go a little fast because of the time limitation. I will talk about leadership and inspiration in ISRO. It's very important for you to understand why leadership is important. And I want to tell you, you have to become a leader tomorrow, not a follower. So you know that you will become a leader. What are the attributes of a leader? Can anyone tell me? You will speak very well. You will stand in the front of when everyone is traveling, and you will take credit for all the accomplishment. You will speak about somebody else's work that I have done that also. What exactly are the attributes of a great leader? The great leader always. Now, don't worry about the names there. There are a lot of names and a lot of people I need to thank for what I am today. But the great leader is to be lead by example. No? Unless you are committed, you are competent, you cannot be a leader. In any domain that you want to be leader, the first capacity that you need to have, you must be competent enough to understand the sector very well. People should come to you for advice. They should see you as a mentor. They should see you as a hope. And they should see you as somebody who will stand with you. And they are ready to forgo the credit. And the others know that you are ready to forgo the credit. The credit will come to you. Automatically it will come to you. And this is something very, very phenomenal impact that you should, each one of you. How many of you work on teams here in college? You make some teams? Sports team, an arts team, magazine team, some project team. You have some leaders automatically coming out of it. And who becomes leader in that group? You said you are the leader, somebody will tell you. The natural leader is one who will come take care of others. The one who naturally take care of others, understand others' weakness, you become the filler. There are a lot of attributes I should speak to you today, and I want to tell you in this hall, I want all of you to become leader tomorrow. Whether others will look at you for hope, others will look at you for support. Not that you will become standard telling I am the leader. No. People will automatically make you leader. I think this is something which I want to tell you. Each one of them showed that path to me, and I want to thank them for this. And this is very important. When I built my first rocket, that was when the first launch was ready. I was much younger at that time. The rocket was going to launch pad, and after launch, the chairman at that time, Dr. Radhakrishnan, signing on my shirt. He gave so much of credit to me for making that launch happen. Though on that day the launch was about to happen, he was firing me. I was crying on the previous week because the confidence level was so low in the success of the launch. But I insisted that we should do this launch. Dr. Radhakrishnan was about to retire just 2 weeks from that date, and he said that why should I take this risk of launching it when there is so much of criticism about this success of this launch. Then I said you must do, because that is a possibility that you have before you. And he listened to me, and we had a successful launch, and he was so proud of that aspect. And you must give confidence to your people, to your leaders, that you can do that. And that will come only because you have knowledge and capacity. Very important. And this happens when Prime Minister Modi came. He also came and congratulated when Chandrayaan 3 was successful. He came. After 2 days, he couldn't come because he was in a foreign visit. And you can see a photo there where I was standing there 15 days after he became the Prime Minister. The first time, 2014, he came to Sriharikota. And I was explaining the rocket we are building, which is yet to be launched in 2014. And that same rocket launched Chandrayaan 3 back in 2023. So I'm really connecting two dots to show you the progress and how Prime Minister himself is mentoring us in terms of building complex systems. So congratulations to each one of you for making this happen. But for us, Chandrayaan series was so important. Chandrayaan 1, how many of you know? 1, that was way back in 2008. And we launched using PSLV rocket, and we found out what? Water on the moon. The mission that found water on the moon was Chandrayaan 1, not Chandrayaan 3. And that we did using PSLV rocket at extremely low cost. And no nation would have ever imagined how to do a moon mission using a rocket which was designed to launch only polar satellite. And we engineered the whole satellite to go to moon and do observation using payloads from other nations, not Indian payloads, because we were not even knowing how to build payloads for moon missions. And this is a great achievement at that point in time. And Chandrayaan 2 found what? Anyone tell me? Chandrayaan 2, what it did? It actually failed in making a soft landing, you know that. But Chandrayaan 2 made the best of images that we have today because of the cameras built by us from the space applications in Ahmedabad, where the Tapanji was the director. It made it the best of ever image. Today, even today, about the moon, 25 centimeter high resolution images are only from Chandrayaan 2 across the world. And we have supplied these images to other nations for enabling this. And now, let us go to Chandrayaan 3. So, and how many of you watched Chandrayaan 3 landing? Very large number of. I think, was it here in this hall or some other hall?
TV. In my home. In my home.
So I know that it was telecast, it was put in YouTube, and Chandrayaan 3 landing was one of the largest viewed YouTube telecast, live telecast of any time. But what I want to tell you is about the rover. Even for a rover, after the landing, 15 days we were working on the mission. And that rover came down the ramp, it actually traveled almost 100 meters on the moon surface, did all the experiments without any issue. The significance of Chandrayaan 3 was not only it made a soft landing, it did all the scientific experiments with a lot of data that was currently available. Even yesterday, there was an announcement of a US national Goddard space flight by AIAA was awarded to Chandrayaan 3, and our ambassador at US received it on behalf of ISRO yesterday. And Chandrayaan received so many international awards and honors. I couldn't go everywhere and collect those awards because I retired. Otherwise, I would have gone because it was such a proud moment for all of us. But then, looking at such wonderful achievement, I think it should be really proud for all of us to realize that making a small, cute robotic equipment, running it on the moon surface using commands from Earth, and seeing that it actually does all the measurements and transmit back to Earth. It's really a wonderful thing to really see and feel it. And I have seen a robot which is, I think you people have made and kept there, no? Yeah. Some people have done here. I think this is something really wonderful to see. Such work is happening here. Young people are building autonomous vehicles and doing softwares, which are very exciting things. And all this were done by young people in ISRO. People who just graduated and came into ISRO, built this complex, small, cute 26 kilogram rover, which actually traveled on the moon and left that imprint of India and ISRO on the sands of, or rather, regolith of the moon. That's really something phenomenal. Now, let me switch it to another domain. This is something for you. Globally, things are happening in a different direction. Though India is doing wonderful in space, you are very proud of the fact that we did rockets, we have moon landing, we are working on human space, but everything is not very good here. I want to tell you that we have so much further to travel. I think this is important for us to understand. I'm not here to talk about praise ISRO or India for whatever we achieve. We want to be aware of what we are and which direction we should go. But if you look globally, you see that the rockets are becoming much bigger. The reusable rockets are coming. Thousands of satellites are being launched by companies like Starlink to build internet services globally. The strategic use of security, use of space has dramatically changed in the last wars between Ukraine and Russia, or even the recent wars which you see the impact of space everywhere. And also the scale of business that is happening in space is dramatically changing. And how do we really go there? We have one issue of technology and the second issue of scale and business. I think this is a separate issue which need to be addressed. And this can come only you people start working in space, not ISRO work in space. ISRO will continue to do the R&D, capacity development, knowledge development, but then you need to become entrepreneurs and start doing things which are innovative, new, service-oriented, business-oriented. And this is where the whole issue is. And we need to understand how globally this is changing and how it is important for universities like you. For us, it is very happy to show this always, that we have done hundreds of launches. We have put almost 100 and odd satellites in orbit, but today we have only 53 satellites in orbit, just 53 satellites. You know how many satellites are there for our neighbor? 500 odd. For globally, there are 10,000 satellites, and our number of satellites are just not enough. Though we do R&D and demonstrations, our reusability is still not visible. Our human spaceflight still not happened. So how do you really close this gap and then reach those levels when India is becoming a very powerful nation in the future? How do you really do that? So this becomes an important topic. So the new space approaches become important. So what are the new approaches? The communication is currently your communication is based on tower, not terrestrial network, and soon it will become mobile network directly from space. And number of constellations are increasing. You know constellations?
Yes, sir.
Thousands of satellites. Can you tell me some constellation other than Starlink? Tell me a constellation other than Starlink for communication. Head of OneWeb? Yeah. Amazon? Kuiper, head of them? Okay, I think you people should look at it globally. Globally, there are a lot of constellations are coming for communication. Similarly, there is a constellation for Earth observation. Hundreds of satellites are launched for looking at whatever you do on Earth. It is trapped. It is captured. Your borders, your fishing, your sea networks, your traffic, your resources, everything can be mapped. And hundreds of satellites are being placed. And space is being used for IoT, strategic surveillance, drones-based surveillance, and many other things. And people are talking about space-based data centers. AI is coming into space. And of course, we have other domains like human spaceflight, interplanetary travel, large-scale technology interventions in space. All of these are happening in another direction. US, last year they launched almost near to 200 launches, and mostly done by one country, one company. Okay, and the next biggest launching nation, China, of course. Then goes Russia, and India, one or two. Europe, not even that one. Last year they launched just 2 rockets. So if you look at globally, this is the change. The reusable rockets have come in the US, and nowhere else it has come, and it has really transformed the sector dramatically. Another thing which you can see globally is that everybody is building small satellites. How many of you seen, is there a rocket satellite company in Kolkata? Are you building a satellite? Yeah, there is a company by Tabanji's family. Okay, they are building a new satellite. You can go and see that. If you have time, it's not far away from here. So there are a lot of satellite companies coming up in India building small satellites. Similarly, there is a high resolution edge computing happening. You know edge computing? Edge computing is to do intelligence in space. You put a computer doing AI and take the picture, you count the number of trees, you count the number of people, you can count the number of cars, you can count the number of ships, tell whose ship it is, identification, you can even identify your face recognition after some time. From space, okay? So this is happening in terms of technology. And a lot of issues related to space debris are happening. Cloud-based services become an integral part of it. And of course, in the defense and strategic side, it's becoming very powerful. So on the defense side, I don't want to go through. There are so many things happening in terms of constellations, intelligence, surveillance. Another area is called data-based services. How many of you are AI studying? Any of you AI people? Yes. I think all of you understand data is your resources, and you operate on AI and you generate so much of wealth and value. This becomes an important issue in space as well. There is a huge amount of data being collected, and even analyzing the data and making sense of it itself is difficult. You know Google Maps? How many of you use Google Maps? All of you use. You know there are roads being shown in Google Maps. Do you find that even a road before it's actually completed, it appears in Google Maps? No? Who is actually putting all that into your village? If you put a road also, it appears in the Google Map. You know how it is captured? It comes in the Google Map. Who is actually looking at it? You know? Yeah, there are technology coming there to capture this change in a very subtle way, pick that information and add to the current information on a regular, continuous manner. And this is an intelligent work which is happening. And this has huge amount of business opportunity. So you can work on data-driven analytics and services, and you don't know how the money is actually created in this. So there are so many issues as far as we are concerned. I skipped because some time I need for something else. Another point I want to tell you is that equally important is to look at how we build the rockets. We have been traditionally building rockets in ISRO, correct? But then today we have transferred rocket building to private companies. You know one private company in India building rocket, anyone can name? That is their own rocket. ISRO's rocket being built by another company. Agnikul is on their own rocket. HAL, LMT, heard about them? They are taken contracts to build up ISRO's rocket in the future. It will not be built by ISRO, it will be built by private companies in the future. We are doing that work such a way that the industry can scale and produce numbers. It will not become responsibility to ISRO to launch in numbers. You see in US it is done by private companies. We need investment, we need agility like a private company to do it in scale. Scale becomes an important issue here. Similarly, we are only looking at how do we really transfer this on a progressive manner. Recently, one announcement has come that we are going to technology transfer of SSLV is already done. A PSLV rocket already announced that it is going to be transferred to industry. So if you have an industry person, you can actually take a technology from ISRO and build rockets today. This is a great change that has come because you opened the space sector. We have also started building reusable rockets. You know, reusability brings down cost of rockets. You know, every rocket after launching it goes down. How much of the mass of the rocket is satellite? Anyone tell me? A rocket is standing on launch pad. You have seen, right? In that there is a satellite. The satellite will weigh hardly 1% of the mass of the rocket, 1 to 2%. Rest of the mass of the rocket is fuel and structure and all of that, and it is going to be wasted. After every launch, the rocket is gone. Assume the rocket can be reused like your aircraft. What would be the return of investment? Huge, no? And that is precisely what is happening when SpaceX does its super heavy rocket. Everything will be reusable, and it can bring down the cost substantially today. For every kilogram you want to lift into space today, the cost is around $5,000 to $10,000, 1 kilogram. And the goal is to bring down to $500, maybe to $100 coming years. And once you do that, space will become very accessible to public. You can also plan your satellite. When space program started in 1960, there were only 5-6 players. Today, how many people have got satellites in orbit, you know? How many nations have got? Can anyone guess? How many nations of the world has got a satellite in orbit? More than 100 nations. And all of them don't have rockets. All of them can build satellites today and get it launched by others. Or even contract to build a satellite and get it launched by others. So it has become accessible for people. So we are actually democratizing space. So space technology is no longer belonging to any elite group. It is actually belonging to each one of you. You can also become a space engineer. You can also innovate. You can also build satellite. You can also launch them. That's what I am seeing in the Indian context. So this I talked to you already. Strategic area is becoming so important. Today, recently, Operation Sindoor, have you heard that how space has become very useful? Yeah, but then in the coming days it is going to become more important because we are going to have missiles being tracked by satellites. Currently missiles are not tracked by satellites, they are tracked by radars, if you know that. But radars, you need so many of them. But if you have a space-based capability through a constellation, you can actually look at the origin of a missile and actually track them along the path and do an intervention, possibly using a laser or a ground-based intervention. So it's going to be the one which is changing. Another area is called spoofing and making satellites disabled. And this is also happening. In ground-based, you pump in power, you can intervene into one of the satellites and actually destroy the satellites, make a defect in case of war situation. You can also look at space domain awareness. What happens during conflict time is your satellites are an asset, so somebody uses their own satellite to make it damaged. So this is happening now. So other nations bring their satellites very close to our satellites and try to do some surveillance on it. So similarly, we want to look at maritime areas. So if you want to look at sea, how ships are moving, it's very difficult to find out in sea. It's a vast ocean. You cannot actually track what is happening. And space is one capacity you can actually do. So there are a lot of things that you can do for surveillance, understanding what is happening on the ground using space, and it is continuously increasing. Today's wars are not going to be like Genghis Khan coming in horseback and then fighting sword and that also changed. Now we were not shooting at each other. The reason was you don't see any army facing each other and firing at it. And you don't even see a troop movement on the ground. Have you seen it in the Operation Sindoor, any troop movement on the ground? Absolutely not. There was not even anybody on the ground. Everything was in the space. You know, there was some backup of the aircraft, some missiles flying, everything controlled remotely, somebody is controlling it, sitting in some room. So the new wars are going to be like this, techno wars, no? So for that you need technology, you need capacity, you need intelligence, you need surveillance. I think this becomes important and space becomes an integral part of it. So we said that to enable this, let us have a space vision, and that's how this Space Vision 2047 came. Our Prime Minister announced this, and I was very fortunate. I was the secretary at that point in time, and he said that we are going to make a 25-year long program for space. One of the goals is that an Indian will go and land on the moon. Why that? Because Americans have already landed on the moon, but why Indians should go and land on the moon in 2040, before 2047? What we are going to get? Not that when you are becoming centenary independent, you should go and put somebody there. It is because that it allows you to progress our technological capacity to a level which is different than today. It is not that somebody will go and land there, but to enable this to happen, I think many things have to happen down the line. What are those things? We are going to build human spaceflight capability. We are going to build a space station where you will be able to do microgravity research. We will be able to do robotic expeditions to the moon. And when you do all of, and we are going to build a huge rocket to put large number of satellites. We are going to bring reusability. And when you do all of that, our sector is going to grow. There is going to be an innovation and corresponding growth in capacity that we are talking about. It's not the man that is put on the moon is important. It is the path and the growth that will happen along the way is more important. And this is the strategic play that we are going to play in the future. That's why we are looking at how do we drive exploration. So, you know, when you send Chandrayaan, what do you really gain is not that we actually landed. We built technology to make it happen. We had algorithms, we have materials, we have propulsion, we have sensors, all done within ISRO using in Indian industries. And this is a strength that everybody respects. And that's why we are going to go to Mars, we are going to go to Venus. Though Venus has been explored many times, but if you do ourselves and do at a very low cost, we gain in terms of technology capacity. We do autonomous operations, we know space commanding, we know how to build sensors. We develop our capacity of people, management, technology. I think this becomes important. And that's why we want to do scientific expeditions and generate knowledge on top of it. That's why we want to continue our moon mission called Chandrayaan 4 and 5. Chandrayaan 4 is to go to moon, bring back samples and study moon. And Chandrayaan 5 is a joint study with Japan. JAXA is going to send a rover weighing 100 kg with nuclear power. And we are going to build the lander and we will be launched in their launcher. And this is a joint program announced by Government of India and we have already approved it. And we are also going to build space station. I think for you people, science people, I think you should look at this as a career option. Because space station gives you a possibility to work in microgravity environment, material research and technology. I think a lot of proposals are already coming in terms of how do we really do medicine synthesis, material science, microgravity studies, growth studies, genomic studies using zero gravity and radiation environment up there. And this is a science capacity that we have to develop. Another important topic which I should talk about is economics of space. I think all of you are going to be not just technologists or people who will actually generate wealth and revenue. Isn't it? Someday if you become entrepreneurs, you work for firms, you should worry about economics. I think economics should become a part of your learning today. And it's very important to understand that it is important to work on low-cost engineering solutions in India. And this is our nation is such a huge nation, but our affordability, spendability is actually still lower unless you have a large-scale penetration. You see anything that you bring in is actually has to be low-cost. And this is very important part of a cost reduction approach. And how do you work with industry, startups to build systems at low cost? This is precisely the reason why we are inviting European and American firms to come to India, set up their industrial production capacity in India, because you can do it actually at maybe less than half the price of the same work that you do in US and other places in India. It's a great capacity that we have. Similarly, the market demand. One of the important points that you people should understand, even space also business is subject to market demand. Now, when America built their rockets, there were no markets for it. They created a market for this. For example, SpaceX created a Starlink constellation to make their rocket to launch thousands of numbers and created an internet service market. So what is a market that we are going to create in India for space? And I can tell you today the market penetration of space capacity is still very low in India. It is used only in some cities and some places. Just 10% of the people only uses benefit of space. We have to reach it to 100% of the people, to villages, rural approaches. So problems in this, down in deeper part of the country, and there is a huge business opportunity. How do you do that? I think this is where the young people have to come. One example I will tell you. Then you will understand. We have our satellite called OceanSat. It produces fish catching advisory. And this data is free at the coastal areas. And nobody uses it because it is free. Suppose somebody uses it as a charged basis, where the fishing, if you use this data and get a better fishing, it can be charged. You can convert it to a business model. I think the idea of business model development is actually technology today. And you can use technology. Whoever is interested to build such a business are welcome to do that. I think there are many such things that you can actually do with the space. Another thing is engineering. I think we need great people to do engineering in India. I have seen this happening in companies like Jadavpur and Skyroot. They are not doing the same way as ISRO is doing. They are doing differently because young people, they are ready to do different way of building. Additive manufactured engines. It's first time built by private company, not by ISRO. ISRO knew how additive manufacture, they had money to build, but they never did because big organizations become lethargic. They become very resistant to change. And young people can do it much faster. That's why after retirement, I am mentoring a lot of young people. I work with young people, young startups. I go there and help them to think differently. And I am very happy to see their energy. That's why I am sure there will be some entrepreneurs of space coming out from this team before I go, willing to build rockets and satellites from Kolkata. Are you ready?
Yes.
That's what we should do. Yes. And new space technology, there are plenty. I think I will go because my time up. I just want to show you some pictures of startup companies where I was really happy to be associated. Skyroot and Jadavpur, all of you talked about it. Both these rocket launches, I was part of their journey. At that time, I was Secretary Department of Space. Today, I am an advisor to them. And they are building their bigger rockets. And there are more people building the rockets. There are at least 5 to 7 satellite building companies. Some of them have already built their satellites and launched today. Recently, there was a satellite company called Galaxy, which was incubated at IIT Chennai, launched their first SAR and optical satellite, but they have some trouble. I believe that hopefully they come out of it. But this is something very interesting to see. And Tabanji is also building this radar in the L band, and possibly it will also go to orbit soon. And we want to see this happen across the country. And for that, what we are doing is we are helping, ISRO is helping all the startup companies to use the ISRO facilities. We say that today Government of India has created these facilities in ISRO for you people to use it. You cannot say, oh, this is a secured area, don't come inside. No. We have to allow young people to come there and use this facility, test your idea, and you can sometimes at free of cost also. Sometimes it's not free of cost because it costs money for anything. So if you start a company, you can actually not invest in high cost equipment, you can come to ISRO and take help. I think this is happening, very interesting thing. We are also transferring technology which is developed in ISRO to private companies at a cost, nominal cost. Like batteries, materials, chemicals, processes, you can actually take it from ISRO. Similarly, ISRO is developing a lot of technology on its own through funding, including robotics, mechanics, atomic clocks, traveling wave tube amplifiers, chemicals, so many robotic activities, and all of these are really available for you to use in case you want. I think that is the point I want to tell you today. After the space sector opening, whatever is done in ISRO is belonging to you. It is not ISRO's private property. It is actually for the whole sector to grow. Of course, there will be some regulatory issues and compliances, etc., which you have to go through, but ultimately it's going to be for you to find out what is actually happening and make use of it for us. So I will skip to a lot of such things are there. Additive manufacturing. How many of you heard about additive manufacturing? 3D printing? Everybody knows 3D printing. 3D printing is exactly additive manufacturing. The other manufacturing is called subtractive manufacturing. You take a metal block, you cut it and take it out material and make something. When you add material to build it, it's called additive manufacturing. So it's called 3D printing. So you can use it with the plastics, metals, and anything. Today, rocket engines and full rockets are built using additive manufacturing. Very important, you should study. Your future is going to be additive manufacturing. Your clothes will be built using additive manufacturing. Your shoes will be built using additive manufacturing. Your food also will be ordered and built using additive manufacturing. Because even synthetic food are being built, including proteins and fats. Animal-derived proteins are used to build synthetic meat and then burgers, etc., using additive printers today. I think that's the level of printing that has grown. There are other domains which are interesting for people. Space domain awareness and space debris. Everybody asks me, there are thousands of pieces around the space. How will you travel to space? 2 months back, one of my colleagues in ISRO resigned and started a company called, I don't say the name. That company is to capture debris and bring back to space. So he's developing a robotic manipulator to go there and capture debris and bring back. It's a great business. You can also join him. Or if you have any great idea, build such technology. Build small satellites. In this university, you start a plan to build small satellites. I want to tell you that if you want to really enthuse people, I want to tell Vice Chancellor, start a program to build small satellites. It's very easy. It requires a few faculty to come together, electronics people, mechanical people, software people, you come together to start building it. It will actually create such a capacity and capability within the students to look at future. I think this is very, very important. Similarly, start some R&D programs on technology, like optics, softwares, sensors. I think this is again important. Similarly, additive and AI/ML. I think some of your AI/ML students should join together to look at how AI/ML can become space ready. I don't know how much of depth that you have worked on it other than large language models or some agentic AI or some work that you are actually doing, some research work is happening in university, Jadavpur University, I'm not very sure. But AI is so much in use in high technology area. Please read and understand because so much of material is outside in the regime for you to understand. Similarly, space is becoming integral part of smart city movement. Head of smart city, where you have connectivity, digital presence, in terms of measurements, traffic management, security, logistics, supply chain, everything connected using space-based systems. But there are many challenges to it, so it's also an evolving domain where there is a business possibility. Similarly, domains like robotics and automation is also becoming very much space integrated. We are building our first robots to go to space, the Vyomitra. I think this is going to be going in the next mission. We are also going to have refueling and servicing of satellites soon. We launched it in one of the PSLV recently, a robotic arm was launched, and we are going to build future robotic activities. And here in this university, you can start such programs. So working on small manipulators and some algorithms related to that. Okay, this I will skip because a little involved. New propulsion technologies are getting developed across like nuclear, hybrid, electric. These are again university-based R&D capacity. Scramjet, vertical takeoff rockets, reusable rocket technologies. Space tourism. You know space tourism? Any company doing space tourism? Blue Origin. Okay. Blue Origin is sending people to 100 kilometers and crossing Kama line and telling all of them are astronauts. I don't know, they are not astronauts. Only if you go around the Earth and come back at least once only you will call them astronauts. I won't call them if you just cross Kama line, say they are astronauts. They spend just hardly few minutes in space and say they are astronauts. But anyway, it's a good thing if you have a lot of money, give the money, 6 crores per ticket and go one trip, good. But before that you make enough money to go there. So you start a space business and become an astronaut, okay. But then the interesting part is there are other companies showing interest like the Virgin Galactic was showing their interest and there are many more companies who are coming up. But then it's not going to be a huge business opportunity as far as we are concerned. But then, why I want to conclude saying that for you young people, say the space is such an exciting area, but understand these 3 things before I close. One important thing is there is something called upstream, midstream and downstream in space. The upstream is where we build rockets, satellites and high technology equipments. They are capital intensive. It takes long time to develop. It has very high risk but low profitability. Okay. But the downstream is basically data, services, aggregation, ground-based equipments, and you make a lot of money there. Almost 60% of the business happens there. But technology risks are low, the gestation period is low, and you can actually start this business much earlier. The midstream is a capacity which is more technically oriented, builds subsystems which will contribute to the upstream. and you become a supplier of various things, and this also is a great business. So I will leave this presentation to you to understand these domains, and I want you people who are graduating to look at all of this in a serious way in the coming days, to look at where you actually fit. And more importantly, do not do it alone. You find out your friendships, create small teams, to look at space as a domain that you will actually look at in creating technology, business, and entrepreneurship in the future. I think I request also some of the professors who will be able to mentor them, at least start discussing with them how do you really create companies, what are the methods by which we seek funding, you create some startup companies, and how IIT KGP's incubation park is there, and many other people are here. The venture fund creation capacity is already existing in Calcutta. How do you use it to create money, bring money and build such capacity? It's very important for you to understand and work on it. Just don't work on your graduation alone. I think while you're graduating, you should also look at how do you really become part of such a movement. I think this is needed for the nation, from at least from space sector side. So with this, let me conclude and thank you so much. So I just really wanted to excite you a little bit.
I'm requesting all the students to please sit down because আগে আমাদের যিনি গেস্ট ডক্টর সোমনাথ বেরোবেন, কারণ নাহলে এখানে এতজন আছে সবাই যদি একসঙ্গে বেরোতে চাও then it will create a chaos. So please sit down. Please wait a little bit.